All right, here we go. So we are on our last conic section, hyperbolas. Okay, hyperbola is the set of all points in a plane such that the difference yesterday we talked about ellipse, and ellipse was the sum, ellipsis, difference, okay, of the distance to two fixed points called foci is a given constant, okay?
So the graph looks like the 1 over x curve. 1 over x.
Similar, but it's not a function, it's a conic, so it has asymptotes. Okay, guys, stop talking. Here we go. I don't know. You're asking me random questions. I haven't said anything. We haven't learned anything. All right. Here we go. Standard form is horizontal hyperbola. Okay. The way that we know it's horizontal, so how do you know it's horizontal is because it starts with x. Okay. If it starts with x and you're subtracting, you have a horizontal hyperbola. Okay. Nope, the A doesn't move. A and B will not move. They stay where they are. It's what it starts with. So if hyperbola, it starts with x, so therefore it's a horizontal hyperbola. Okay. And then from there we'll keep going. And yeah. So next you're gonna talk about finding your center. Your center is still gonna be what? HK. It does not change. Next, we're gonna talk about our vertex and our foci. So our vertices. Your vertices are where you begin on your hyperbolas. So on each branch, so this is our right branch, this is our left branch. To find your branches, notice that it's 8 units away from your center, okay? So it's gonna be our center H plus or minus A, comma, our K. Okay, your foci, again, are still on this horizontal plane right here. And this right here tells you that it's C distance, C units away from our center. So we're gonna have H plus or minus C, comma, K to find our foci. All right, next is our asymptotes. Our asymptotes are gonna be our boundary lines, our imaginary boundary lines that keep our hyperbola along that curve. So to find your asymptote, it's going to be y equals your k plus or minus your b divided by your a times x minus h. Okay, so if you look right here, do you remember how we did slope was rise over run? So this is our rise. So we're rising and then we're running. Oh. Okay. All right, and that's your asymptotes. Next, now we're going to look at a vertical hyperbola. So if you look at the vertical hyperbola, it's vertical because you start with y and you are subtracting. That's what makes it a vertical hyperbola. Yep. If we weren't subtracting, it would just be an ellipse, because ellipse is the sum. Okay. All right. So going through again, identifying center is still what? HK. Our vertices. This time our vertices are vertical. So our H is staying the same, but our K is what's changing, right? So our K plus or minus our A. Our foci are also along this vertical plane. And we are C units away from our center. So our H is staying the same, but our K plus or minus C is going to give us our foci. Okay. Our asymptotes this time. So our asymptotes now is y equals K plus or minus, and again, our rise over run, this time we rise A and we run B. So it's going to be A over B times x minus h.
So it's just.
Good thing you're allowed to make one of those, huh? All right, next for your test. I said, good thing you're allowed to make one. All right, so to find your C, this time we're adding. So it's the sum of our squares versus last time it was the difference of our squares, right? So your C equals the square root of a squared plus b squared. Okay, note with hyperbola, your A is always going to be first. It's going to stay alphabetical. It does not follow. It doesn't matter anything about smaller, larger denominator. Okay, it's always A, then B for hyperbola. All right, let's graph one. So here we have x minus 2 squared divided by 9 minus y minus 3 squared divided by 25 equals 1. I know that it's a hyperbola because I am what? Subtracting, okay? So now I got to determine, is it a horizontal or a vertical? It is horizontal because x is first. Got it? All right, your center depends on your h and your k for this problem. Our h equals 2, our k equals 3. So our center is 2, 3. I didn't mean to write it there. I don't know why I wrote it there. It takes up a space. So we have our h and we have our weird looking attempt of a k. There we go. Your A is the square root of your first denominator, and your B is the square root of your second denominator. So A equals the square root of 9, which is 3. B equals the square root of 25, which is 5. Okay. Your C equals the sum of your squares, the sum of your denominators. The square root of it, sorry. C equals the square root of 25 plus 9, which equals the square root of 34. So we have the square root of 34, which is going to be approximately 5 and 83/100. Okay, your foci. So remember, your foci is going to be your H plus or minus your C. So our H is 2. Our C is 5.83. So 2 plus 5.83 gives us 7.83. And our K is still going to be 3. And then minus 2 minus 5.83 gives us negative 3.83. Right? 2 minus. It's your H plus and H minus. Okay, your vertices are going to be H plus or minus your A. So 2 plus 3 gives us 5. And then 2 minus 3 gives us negative 1. Okay, and then our asymptotes. For graphing, we're going to graph it a lot easier, but our asymptotes are, so y equals your k. What is your k value? 3, right? Plus or minus b over a. So 5 over 3 times x minus h, which is 2. Okay, 5 over 3, this is just our what? Our rise or run, our slope, correct? All right, so we're going to graph our centers. We're going to go to 2, 3. 1, 2, 1, 2, 3. Okay, from my center, I like to go ahead and find my my asymptote, because my asymptote is going to intersect here. Does that make sense? That's where the center is where your asymptote. So to do that, all I'm going to do is apply my slope. Now, if you didn't want to apply the slope, could you graph and grab some points? Yes, but you could do this without it. I plotted my point. I'm going to rise and I'm going to run. So rise 5, 1, 2, 3, 4, 5, 1, 2, 3. And then go down 1, 2, 3, 4, 5, 1, 2, 3. And I know that this is going to be my asymptote with the positive slope. Now, to find my negative, this time I'm going to rise and then go to the left. 1, 2, 3, 4, 5. 1, 2, 3. I'm going to fall and then crawl to the right. 1, 2, 3, 4, 5. 1, 2, 3. And now I have my asymptotes. Was that terrible?
How hard is that?
My rise over my run? I rise and I run. Oh. And then your vertices, we're at 5, 3 and negative 1, 3. So I'm going to go to 5, 3, 3, 4, 5. I'm going to go to negative 1, 3, 1, 0, negative 1. And then I'm just going to follow my asymptotes out to get a rough sketch of my hyperbola. And there is my hyperbola. You could also go ahead and graph your, what's that thing called? Your foci. If you want, they're like here, here's 1. And then the other one's at 7 and some change. Okay, what seems hard about this? There's a lot, they're different. There's 4 of them. So there's 4 of them, there's a lot.
Oh, okay.
I was like, yeah, there's a lot. No, I'm agreeing with you. No, I was not. I was not. I'm sorry. I'm very sleepy. I apologize if it came off any other way. All right. So for the sake of time, I'm just going to kind of go through and make sure we're comfortable identifying what they are. And then we're going to need to go to the conic form of it. Okay. All right. So looking at number 2, is it going to be horizontal or vertical? It's going to be vertical. That's because my Y is leading. Does that make sense? Okay. Number 3, vertical or horizontal? Horizontal because my X is leading. Okay. Make sense? And if it had became a sum, then automatically is no longer a hyperbola, is now a what? Ellipse. Okay. All right. Now we're going to talk about the conic form. It's the same thing that we did for ellipses. Okay. You're still going to follow the exact same 4 steps. Got it? The difference here with between ellipses and hyperbola is that hyperbola, your A and your B have different signs. One has to be negative, the other has to be positive. You have to have that positive negative in order for you to have a hyperbola. If they are the same sign, then it is an ellipse. Okay. So when I look here, I have a positive 11 and a negative 4. That's how I know it's a hyperbola. Do we see that? Okay. Well, you're going to go through the same steps that we did before. We're going to move our constant and regroup. So step 1 is to move the constants and regroup. So my constant is negative 49. It's going to move. I'm going to regroup. I have 11x squared minus 22x plus negative 4y squared minus 16y equals 49. So we moved our constant and regroup. One of the biggest mistakes that I see people do is they forget to carry the sign with the term. Okay. If you're subtracting, that's adding a negative. So you need to carry the sign with the term. After we do that, then we're going to factor out our leading coefficients and complete the square. Factor out our leading coefficients and complete the square. Our leading coefficient here is 11. So we factor out 11 and we're left with x squared minus 2x. And I'm going to complete the square, which would make this a 1. Factor out my leading coefficient, which is negative 4. Factor out negative 4, and I'm left with y squared plus 4y equals, not equals, 4y plus 4. Yes? Okay. Equals 49. Because we factor out, we're not just adding 1 and 4, we have to add 11 times 1 plus -4 times 4. Okay, so that's step 2. Factor out, complete the square. Step 3 is to factor and simplify. So this becomes 11 x minus 1 squared minus 4 y plus 2 squared equals, what is that? 44? Equals 44. Okay, all right, how do we feel about step 3? And then the final step is to divide by your constant and simplify. So I'm going to divide by 44, divide by 44, divide by 44. And we're left with x minus 1 squared over 4 minus y plus 2 squared over 11 equals 1. And here we have a what kind of hyperbola? Perfect. Okay, and that's what you're doing. And you just keep doing the same 4 steps. And that is hyperbolas. Okay, the rest at this point, it's become pretty repetitive on us getting the graphs and everything. So the rest is for you to practice. If you have questions, let me know. I'm here to help. But that's it. That's where we're going to end our conic set.
All
right.